myself Ribha, and today I'll tell you a story of polyhedra. So, to begin with, first of all, what is a polyhedron? Polyhedron is a three-dimensional object which is composed of flat polygonal faces, and each pair of adjacent faces, they meet along a line segment which we call as edge, and adjacent edges meet at a corner which we call vertex. Polyhedron could be regular or irregular. A regular polyhedron is always convex, which means that a line joining any 2 points inside a polyhedron will always remain in the interior of the object. Here, every face is the regular polygon. As we see, every face is a regular polygon, and all faces are identical. Every vertex is surrounded by the same number of faces. Now, there's a Greek theorem which states that there are exactly 5 regular polyhedra, which means in nature there are just 5 regular polyhedra. And this is the proof of this theorem, which I'm skipping for now, but if anyone wants, I can explain it later. So polyhedra as Fibonacci sequence is found everywhere in nature. For instance, crystal of salt is a cube, which is a polyhedra. The unit cell of water is a tetrahedron, which consists of 5 water molecules connected by hydrogen bonds. Here I have a picture of a single-celled organism called Radiolaria, whose internal structure resembles a polyhedra. Almost all viruses in nature, they have the symmetry of icosahedron. Now, this was not accidental that they looked a virus through microscope and they found that it resembles the icosahedron and they said, oh, we found another polyhedra in nature. But this is on purpose why viruses take this shape. Because viruses, they want to save a huge genetic information for which they want large volume for a given surface area. And from the all platonic solids, icosahedron have the largest volume for the given surface area. And even proteins taking shape of icosahedron consumes less energy as compared to other structures. Now, it also have other biological reasons like nucleic acid, proteins. So, there are many other biological reasons behind why viruses take this shape. Even you would have heard about fullerenes in your chemistry class. Fullerenes, they are the large carbon molecules containing all carbon atoms, where each carbon atom is bonded by exactly 3 of its neighbors. It is also a polyhedra. Okay, I was talking about fullerenes, that you would have studied about fullerenes in your chemistry class, which is again a polyhedral molecule containing all carbon atoms, where carbon atoms form pentagonal and hexagonal rings. As we see here, C60 Buckminster fullerene molecule, it is a truncated icosahedron. Fullerene also have a great importance in medicine. For instance, it is used as a light-activated antimicrobial agent. It is also used in several medical applications, including design of high-performance MRI contrast agents and many other things. So, before the great Swiss mathematician Leonhard Euler, the theory of polyhedra was over 2000 years old, but still it was all geometric. As scientists, they focused on the matrix property of polyhedra, that is the properties that we could measure, for example, finding area, volume, and finding the length of the side. But Euler, he wanted to have some different approach, and he wanted to classify polyhedra by counting some features. Now, the thing which will come into your mind is, let's count the number of faces and classify polyhedra. But we can see here, the polyhedra with the same number of faces could look quite different. And he quickly came up to the conclusion that in a polyhedra, if we count number of vertices, edges, and faces, we'll find this relationship that V minus E plus F will always give you 2. And this is the example showing that all polyhedra follows this relationship. Now, the proof given by Euler was very complicated, and it could not meet the rigorous needs of today's standards. So, the second published proof of Euler's polyhedron formula and the first to meet today's rigorous standard was given by Adrien-Marie Legendre, who was a French mathematician. Now, the success of this proof was really unexpected because he used the concepts from spherical geometry and various matrix properties of sphere. But Euler, when he discovered this relationship, he never mentioned any characteristics of geometry. This is the proof which states that this formula holds, which again I'm skipping for now. 2 slides. Now, this Euler's formula also have its application. As I already told you about fullerenes. Now, there are infinite number of fullerenes that are possible. Now, remarkably, without knowing chemistry, but just knowing mathematics, we can say that what certain configuration of fullerenes are possible in nature. It could be done by the 12 pentagon theorem, which states that every fullerene which consists of hexagonal and pentagonal rings will have exactly 12 pentagons and any number of hexagons. And the other famous application is, there was an old and interesting problem that asked that how many colors are required to color a map in such a way that two neighboring countries sharing a common border do not have the same color. And it was discovered that we required just 4 colors to complete a map in such way. And this came to be known as a 4-color conjecture, which again used Euler's formula.